So seem to enjoy that very simple video on that algebra problem before. So I tell you what I'm going to do. I'm going to look at this one. It's one of my favorites. Sine x, I'm going to write it like this, all squared plus cosine x squared is equal to 1. Why? This can also be written, if you ever see the sine squared x plus cosine squared x, it can also be written like that. But why is this true? It's like no matter what value of x that you put in here, you will always end up with this expression making 1. Now, if you are able to imagine or explain is probably better, if you're able to explain the answer to this question in pretty much a sentence or maybe two, then you fully understand it. And if you are able to, well done. It's not actually that hard. I'm going to connect some concepts together. This is Pythagoras. So this is a right-angled triangle. But what I'm going to do is I'm going to make the length of this side 1. Now, how many right-angled triangles can I have with a length of 1? Well, there's an infinite number of them. But if I take this point here and I was to trace this point for all of those triangles that I could possibly have, what would I get? So what you're doing is you're keeping the one the same length, and then what you're doing is you're changing, say, this angle, because that's the only thing you can do. You know, we're going to keep that still. We're going to change this angle, and what you're actually going to end up with is a nice circle. If I call this x and I call this y, you're going to have to treat that as different from what I've just said here. Just note that I could have x here, but I could put any variable in there. In fact, I'm going to change it to alpha. Sine squared alpha plus cos squared alpha equal 1. So that way you're not going to get confused with these x and y's here. So x, y, for any particular point, can you guess what alpha is? Now, you wouldn't need to guess what alpha is if you immediately, understood what sine and cosine actually are. But one of the things I have found, because I like to teach mathematics to people, is the connection between sine and cosine and something else, the most obvious connection between the two. In fact, the definition of what sine and cosine are, because you've got to remember sine and cosine they're an invention. Nobody discovered the sine function. Nobody discovered the cosine function. Not really. They discovered something else, and then they created a sine and cosine function as a way of describing something about that thing. Right? But they could have been called anything. So what are they? What are these sine and cosines? If you have ever drawn a circle using sine and cosine, why didn't you make the connection just now? Maybe you did. Maybe you just made the connection just now. But I'm really interested in the people who are just going, I don't know, what on earth is he talking about? And then the belly slowly clicks, right? Because this is alpha. And the definition of sine is the position on the y-axis of this point. And the definition of cosine of alpha is the x-coordinate. Sine and cosine are telling you the coordinates of a point on a circle of radius 1. That's all they are doing. That's it. Some people might say, well, that's obvious, but I know it's not obvious because I have looked at many puzzled faces in my time, and for some reason when they teach these things, they don't make sure, they don't lock in the connection between sine and cosine and the circle. All you tend to hear when you're talking to people about sine and cosine and so on, they say, so SOHCAHTOA. It's like, never mind that. I mean, it annoys me a little bit because it's just, look, if you don't teach, it's a problem of teaching. If you don't teach and drill into people's heads that sine and cosine are the definition, are defined in a very clear way. They could have been defined any other way. They don't come from anywhere other than they are invented. They are a standard. The standard is for this angle measured from the positive x-axis in an anti-clockwise direction, okay, by some units. There are different units that you can use to measure the angle. Degrees are the ones that we're all familiar with, most familiar with. Radians are the ones that are most useful mathematically. So if we do degrees, we can say the degrees here of this angle to the x-axis rather than any other axis, positive x-axis, you know, and going in an anti-clockwise direction. And for any angle alpha, if this is a distance of 1, you can measure this and x here, and you measure this y, and that y is the sine of alpha, and x is the cosine of alpha, because they're defined to be like this. Not because, of course, people say, well, why are they like that? It's because we decided that they're like that. It's a standard. It's like you from a circle. You're interested in knowing where this point is. For any angle here, long time ago, they saw that this was interesting, and it is interesting, and so they actually measured different angles and measured these distances, and eventually a pattern was discovered. Now, if you take that and get it turning, it's getting increasing at a steady rate, you will obviously have this go round and round in a circle. And then if you look at the height of this over time or angle, right, as the angle increases, this is going up and down and up and down and up and down as a sine wave. That's where the sine wave comes. And if you look at this way, it goes that way and this way and that way and this way, and that gives you another curve which is also a bit, looks like a sine wave, and they're out of phase by 90 degrees, which of course they would have to be, because one is for this axis and the other one is for this axis. But we come back to this question: why is this always 1? And you look at that and you see, hang on a minute, this is a right angled triangle. I remember that Pythagoras-y thing, which basically said x squared plus y squared is equal this side squared, which is 1 squared, which is the same as saying 1. 1 squared is 1. So in this case, for a circle of radius 1, this is x squared plus y squared equals 1. But x is cosine alpha, y is sine alpha. Oh, so this goes there, this goes there, and, well, there we are. Cosine of x squared, cosine x all squared, right, plus sine, alpha, I beg your pardon, alpha all squared is equal 1. Well, when you see this, that's it. I mean, ta-da! If you can understand that fully, that will help you understand so much, because this is actually a foundational piece of information to help you make sense of a lot of other stuff, like all of trigonometry and so on. And but where you see this written down, you will often see it written down like this: cosine of x plus sine of x equals 1. And the reason they use x is you could use any letter, and very often when people write formulae down or equations down, that use x to represent the thing that varies. So, you know, that can cause confusion if you're thinking, well, it's not this x. This is why I drew the line. It's sort of in here, x squared, cosine x squared plus sine x squared equals 1. I hope that was of use. Please give me some feedback, because if people like this kind of stuff, I want to do some more. Small little fragments that help you understand mathematics that you really shouldn't be scared of, because what's there to be scared of this? It's easy, isn't it?